So to start the problem, we have to draw the free body diagrams on the two systems. But we have to realize that for the 5 kilogram block and the 2 kilogram block, they share a tension with third law of pairs, which means it's equal and cancels out. So that's one system. And then from there, for the 3 kilogram block, there's tension on the block by the string and weight on the block by the earth. And it's going to be going up with acceleration, so we made up positive. And then on the 7 kilogram block, which is 5 kilograms plus 2 kilograms, we have the tension on the block by the string and the weight on the block by earth. And it's going to be moving down with acceleration, so we made down positive.
So then the acceleration for both the systems is the same because they're on the same pulley system. So that's why we made A positive in this direction and then A negative in this direction, because that way later on you can set the two accelerations equal to each other. Also, the string is massless, so then that's how you know that the tension is the same throughout the string. So then the tension for system 1, the 3 kilogram block, and the tension for system 2, the 7 kilogram block, are the same. So we just focused on system 1 at first. So we just used the equation, the sum of the forces in the y direction is equal to the mass times the acceleration in the y direction. So basically what we have here is the sum of the forces is equal to the tension minus 30 newtons. And we got the 30 newtons with the WBE, which is just mass times gravity, so that's 30 newtons. So then, again, the mass is 3 kilograms. So AY has to be the sum of forces over m, which is equal to T minus 30 newtons over 3 kilograms. And then moving on to system 2, which is the 7 kilogram block, the sum of the forces is equal to 70 newtons minus T. And again, we got the WBE just by multiplying the mass times gravity, so that's 70 newtons. The mass, again, is 7 kilograms, and you don't know the acceleration. So acceleration in the y direction is equal to the sum of the forces over the mass, which is equal to 70 newtons minus T over 7 kilograms. And we know that the acceleration is the same for both the first system and the second system, because like we said before, they're on the same pulley system.
So now we can set the two systems equal to each other since they both equal acceleration in the y direction. So now we have 70 newtons minus T over 7 kilograms equals T minus 30 newtons over 3 kilograms. So if we cross multiply, we get 210 newtons minus 3T equals 7T minus 210 newtons. Then when we solve for T, we get 420 newtons equals 10T, so T equals 42 newtons. Then we can plug in 42 newtons into the equation, acceleration equals force over mass. So 70 newtons minus 42 newtons all over 7 kilograms equals 4 meters over second squared, and that is your acceleration. And for F and G, since the strings are massless, they are equal to each other, and so the tension for both are the same, so they are both 42 newtons.